Welcome to this lesson on descriptive and inferential statistics fundamentals. In this session, you'll learn how statistics help us summarize data, uncover patterns, and make informed conclusions. By the end of this lesson, you'll understand the difference between describing data and making inferences from it. What is statistics? Statistics is the science of collecting, analyzing, interpreting, and presenting data. It helps us turn raw numbers into meaningful information that supports decision-making in research, business, and everyday life. Why statistics matters? Statistics matters because data alone doesn't explain anything. Statistical methods help us understand trends, compare groups, measure uncertainty, and make evidence-based decisions instead of relying on assumptions or intuition. Two main branches of statistics. Statistics has two main branches, descriptive statistics and inferential statistics. Descriptive statistics summarize what the data shows, while inferential statistics help us draw conclusions beyond the data we directly observe. What is descriptive statistics? Descriptive statistics focus on summarizing and organizing data. They answer questions like, what is typical? How spread out is the data? What patterns do we see? These methods describe the data we already have. Types of data in statistics. Before applying statistics, we must understand data types. Common types include numerical data like scores or income, and categorical data like gender or department. The type of data determines which statistical methods are appropriate. Measures of central tendency. Measures of central tendency describe the center of the data. The mean is the average, the median is the middle value, and the mode is the most frequent value. Each measure provides a different perspective on what is typical. When to use mean, median, or mode. The mean works well for balanced data, but it's sensitive to outliers. The median is better for skewed data, such as income. The mode is useful for categorical data. Choosing the right measure improves accuracy. Measures of variability. Variability shows how spread out the data is. Common measures include range, variance, and standard deviation. These help us understand whether data points are clustered closely or widely dispersed. Understanding standard deviation. Standard deviation measures how far data values typically deviate from the mean. A small standard deviation means values are close together, while a large one indicates more variability in the dataset. Visualizing descriptive statistics. Charts support descriptive statistics. Histograms show distributions, box plots highlight spread and outliers, and bar charts summarize categories. Visuals make statistical summaries easier to interpret. Introduction to inferential statistics. Inferential statistics allow us to make predictions or conclusions about a larger population based on a sample. Since we can't measure everything, inference helps us estimate and generalize responsibly. Population versus sample. A population includes all individuals of interest, while a sample is a subset of that population. Inferential statistics use sample data to make statements about the population, assuming the sample is representative. Sampling and bias. Good inference depends on good sampling. Biased samples lead to misleading conclusions. Random and well-designed sampling methods reduce bias and improve the reliability of results. Introduction to probability. Probability measures the likelihood of an event occurring. It ranges from 0 to 1. Probability provides the foundation for inferential statistics by helping us quantify uncertainty. Confidence intervals explained. A confidence interval provides a range of values within which a population parameter is likely to fall. For example, a 95% confidence interval suggests we are highly confident the true value lies within that range. Hypothesis testing basics. Hypothesis testing evaluates claims using data. We start with a null hypothesis, collect evidence, and determine whether the data provides enough support to reject it. This process helps avoid guesswork. Understanding p-values. A p-value measures how likely the observed data would occur if the null hypothesis were true. A small p-value suggests the result is unlikely due to chance alone, indicating statistical significance. Common misinterpretations. Statistical results can be misunderstood. Statistical significance does not always mean practical importance. Also, correlation does not imply causation. Always interpret results within context. In summary, descriptive statistics help us understand what the data shows, while inferential statistics help us make conclusions beyond the data. Together, they form the foundation of data analysis and evidence-based decision-making. Thank you for watching.